Nowadays they are the backbone of electronics and robotic systems. Stepper motor is an electric motor whose main feature is that its shaft rotates by performing steps. That is, moving by a fixed amount of degree. As all with electric motors, stepper motors have a stationary part called stator and a rotary part called rotor. Majorly in stepper motor, it has teeth for accuracy and positioning rotary. As shown here, on the stator, there are teeth on which coils are wired, while the rotor is either a permanent magnet or a variable reluctance core. Basic working principle of stepper motor is that, by energizing one or more of the stator phases, a magnetic field is generated by the current flowing in the coil and rotor aligns with the field. By supplying different phases in sequence, the rotor can be rotated by a specific amount at each desired final position. As I have said, the rotary part of the motor can consist of permanent magnet rotor, or it can consist of variable reluctance rotor. Variable reluctance rotor is made of an iron core and has a specific shape that allows it to align with the magnetic field. Therefore, when we combine the permanent magnet with variable reluctance rotor, we form what is called hybrid. With this solution, it is easier to reach a higher speed and resolution, but the torque it develops is often lower. Stepper motor must have a controller. For example, a transistor bridge, which is the device physically controlling the electrical connection of the motor coils. Controller can also consist of a pre-driver, which controls the actuation of the transistor, providing the required voltage and current. It is in turn controlled by an MCU. An MCU is a microcontroller unit, which is usually programmed by the motor user and generates specific signals for the pre-driver to obtain the desired motor behavior. Stepper motor driver types consist of step or direction. Here, by sending a pulse on the step in, the driver changes its output such that the motor will perform a step, and the direction of which is determined by the level on the direction pin. Another type is phase or enable. For each stator winding phase determines the current direction and triggers enable if the phase is energized. PMW directly controls the gate signals of the low side and high side FETs. Stepper motor driving techniques can be categorized under 4 categories: wave mode, full step mode, half step mode, and micro-stepping mode. In wave mode, only phase at a time is energized. For simplicity, we will say that the current is flowing in a positive direction, hence approximate of 60 degrees can be made in each step. In full mode, we energize the 2 phase at a time and change the direction of current. Hence it can make 180 degree per step. In half mode, we combine the wave mode and full mode. Hence we can achieve an accurate of 90 degrees per step. And in micro-stepping, by controlling the intensity of current flowing in each phase. Using this mode requires a more complex motor driver compared to the previous wave mode, full mode and half mode. If the Imax is the maximum current that can flow in a phase, starting from the left, IA is Imax, and IB is 0. In the next step, the currents are controlled to achieve IA is 0.92 and IB is 0.38, which generate a magnetic field that is rotated by 22.5 degree compared to previous step. Another important feature of a stepper motor driver is that it only controls the voltage across the winding or current flowing through it. With voltage control, the driver only regulates the voltage across the winding. The torque developed and the speed with which the steps are executed only depends on motor and load characteristics. Also, current control drivers are more advanced, as they regulate the current flowing through the active coil in order to have better control over the torque produced. And thus the dynamic behavior of the whole system. And the main advantage of stepper motor is that there is no need of sensor feedbacks like other motors, including servo motors. Watch servo motor video to know how it works. Check our previous video. I hope you found this video informative, and if you did, kindly subscribe, like and share. See you in the next one.